Thank you everybody for joining today. As Ben said, what we're going to be doing is a level 1 class. So the official topic was room layout and acoustic treatment. 1 hour on that subject is challenging. We'll do our best to introduce some of these topics though. There's plenty of time to ask questions. As Ben said, just pop them in the chat. And what we'll do is we'll come back and address those questions at the end of the session, guys. Okay, so for those who perhaps don't know me, although I see quite a number of my own staff on here, hi guys. So my name is Neil Davidson. I'm Managing Director of Genesis Technologies Limited. So I've been involved in cinema design for a long time now, not quite 30 years, I'm pleased to say. I've got my ISF badges, my HAA badges. This was a fun one. I went over to Canada and I got my IMAX Certified Home Cinema Technical Expert badge. Always an interesting story over a beer, that one, I have to tell you. I also have several other businesses which are involved in cinema. So I have an acoustic treatment company. I have a projector screen company called Display Technologies Limited, based in Yorkshire, yet another Yorkshire company. I own a speaker company called TPI Cinema. The factory is in Leicester. So we make high performance speakers and amps. And believe it or not, several others on top of an already long list. So I like to show those things. Not to show off or anything like that, but I've been lucky with Genesis Technologies. We've always been involved in amazing projects in the 15 or 16 years now that the company has been operating. And because of that, you get to see what people need in the marketplace. And I've been lucky enough that when, you know, over a few beers, you have a mad idea to do something new. Those ideas have worked out for us, and it's spun off into this group of companies now, which I'm very proud of, and hopefully you guys will be able to check out as well. So that's enough of that boring stuff. Let's move on to the actual training that you guys have signed up for today. So what we're going to try and achieve, so look, it's a level 1 session. What we want to do is introduce these topics without going too in-depth on everything. So we want to define what is sound. That's the first thing we have to define. Then we're going to discuss sound isolation, then acoustic treatment. And we're going to introduce some key considerations that will hopefully get you thinking about these subjects. So first of all is on room construction. Weak points that you need to watch out for when you're looking at room construction. Then your acoustic treatment tool set and the role of acoustic treatment in cinema designs. And also the importance of room layout. Okay. So, first of all, what is sound? I always think it's important that if we're going to talk about acoustics and isolation, that we actually define sound. So sound is just simply movements of our eardrum caused by waves of varying pressure traveling through space. It's pressure that causes us to hear as it acts on your eardrum. Now, as the pressure of the wave increases, your eardrum moves more and you hear sounds as being louder. That's what sound is, and that's what loudness is. Now, what we hear, it's actually a complex sum. So it's all of that stuff added together. from all of the sources that we are listening to at any given time. So Dave in his car there, he probably hears some traffic noise that's going on around him. You know, he hears us coming out over the radio. Someone who's sitting at home, yeah, Nikos has got his headphones on, so probably he's a bit more isolated from the rest of the environment, and he can really focus on those sounds that are coming in. But it's very interesting to know that it's all of the things that are going on are what we hear. Now, as you would imagine, because of that, louder sounds mask quieter sounds. It's pretty obvious if something's louder, that's what you're going to hear. But then you get all of these interactions, and sometimes they can mask and sometimes they can emphasize other certain frequencies. That's always an interesting one to just bear in mind as well. Now, here's a question for you. Does our hearing have a flat response? So we're all used to, I'm sure, hearing that we want to have a flat response in our cinemas from our speakers, okay? So does our hearing have a flat response? Well, here's a thing called a loudness curve. So a loudness curve is kind of like a normalized over 100 people sample of how our hearing actually works. And it's quite interesting to note that our hearing is not at all flat. What the chart shows us, in fact, is that our perception of sound changes with loudness. So each of those colored lines on that chart, that's as the sound gets louder. That's how we respond and perceive those sounds. It also changes with frequency. What the chart is actually showing us is that we are much less sensitive to low frequencies. What it's actually showing, if I grab my pen here, my laser pointer, it's showing that the loudest possible sounds, the quietest possible sounds are dramatically different in bass compared to a perception of like a mid or a high frequency sound. That's a really important thing to understand. Because if you remember that a change of 10 decibels is twice as loud in perception. So if we look at a fairly loud sound here, 100 decibels of bass is perceived at being at roughly the same loudness as what, 40 decibels at 2 kilohertz. That's a massive difference in actual loudness. Now, as you will imagine, that has a big impact on sound isolation and system design, is what it says behind my head there. Because we don't hear sounds as being completely flat. Now, obviously the biggest thing there that you can see is that we are much, much, much less sensitive to bass frequencies than we are to higher frequencies. It's why your subs need to be able to play that much louder, why the content is encoded that much louder for the subs to give a bit more perception. The other thing though is, many times have you had a client who said to you, you know, I wish you would turn the surrounds up a bit for me. I don't hear them when I'm watching the telly. Well, if you go in and you get the test tones going and you're playing here at this sort of a loud level, but the client only watches the system down here at this much more quiet level, really the sound will be different. They will hear it differently. You will hear it differently. So that's just something to consider. It's not always that the client is wrong when they say that they can't hear it. It's probably just that they're listening at a different volume level than what you set it up for. And it took me a long time, I have to tell you, to understand why that was. But it's a really, really important one to remember. It's not everyone that likes to have it playing 105 dBs all day long. So yeah, loudness, controls, and all that type of stuff. In fact, it's all linked to this table here about how we perceive loudness. I always like to show that one because it does have such a big impact on the kind of rest of the topics that we're going to discuss. So first of all, let's look at sound isolation versus acoustic treatment. So one of the most common confusions in, well, I've said acoustic design, in cinema design, sound isolation and acoustic treatment are not the same thing. They're not the same thing. Sound isolation design is all about keeping sound inside or outside a room. There's Dave with his car again. What a useful example you are, Dave, I'm afraid. Dave in his car, he wants to have as much sound isolation as possible so that the road noise is kept out of his car. You know, that could be in our front room, the same example. You don't want that noise to come in, you want it to stay outside. In a cinema, that's also a big thing. You don't want air conditioning and all that type of stuff, fans and whatever else making noise in the room. At the same time, you don't want it to leak out into the space. Acoustic treatment design, on the other hand, it's all about improving the quality of the sound within a room. Now, should be no surprise to learn that the best results are going to be had when good sound isolation is partnered with good acoustic design. That's when you get the best results. Now, a question for you. Are these only relevant to cinemas? Now, I would say that one of the best opportunities that you guys have got is actually looking at these subjects elsewhere in people's houses. I gave the example about sound isolation. Well, you know, bedrooms and stuff like that. These days, people are aware of those things. You know, your client lives next to a road. I'm sure they would be very, very interested to talk to you about sound isolation. If you look at acoustic design, many of these big kitchens do you go into in your clients' houses these days, it's all beautiful, hard materials, marble tops, tile floor, maybe a marble floor as well. But you can't talk to each other. The sound echoes around the room for so long, it becomes an uncomfortable place to be. Now, I actually find that a lot, that obviously you guys understand I don't talk directly to end clients very often, but when you're on these sites, you'll hear them saying, oh, I can't hear what's going on in this kitchen, or the sound from my speakers is terrible in here, or I can't talk to my husband across the table. They're saying that the acoustics are bad. And if you can solve that problem, let me tell you, they've got a lot of money for you to solve that problem. And it does not need to be done in a way that destroys that clean aesthetic that they're looking for. That's also very, very important. Okay, so just think about that. We're going to kind of focus on cinemas in this session, but these things can be applied much, much more widely than just to cinemas. So moving on to sound isolation. The goal of sound isolation is to keep sound in or out of the room, as we just said. Now, sounds with a long wavelength are much harder to block than sounds with a short wavelength. So if everyone's trying to remember their high school physics at this minute in time, we've got some good news for you. Long wavelength equals low frequency. Okay, that's your bass sounds. we're much less sensitive to low frequencies than we are to high frequencies. That's what those curves on the last slide showed us. Now, long wavelengths are much harder to block. That's why when you go out of the room, it's not like the voices and stuff that you hear, it's the boom, boom, boom of the bass. It's because of the wavelength and the difficulty in containing that. Now, there's a nice tool set that we have to consider when it comes to sound isolation. So mass, can you get a nice heavy structure? Damping, that's a really important one. You don't actually want that structure to be completely rigid. You want it to have a little bit of flex, because that flex helps to absorb the energy. It's changing the energy into movement. You don't hear movement, so that's a good thing. You want to decouple. Conscious decoupling, that's what we're looking for in this one. So decoupling, what does that mean? It's like if you take a subwoofer and you put that straight onto a concrete floor, you're going to get more of that sound transferring through the structure. And that's very tough to control, actually, sound transfer through a structure. By decoupling, you prevent that. You prevent the sound from moving through a structure in a way that you don't want it to do. And impermeability. PowerPoint tells me I've spelled this wrongly. All that means is that it's just airtight. Okay, the more you can stop the air from moving, again, the better you're going to be, especially at high frequencies, right? That's going to be a big bonus for you. Of course, don't take the chance of making an airtight room for your client. That's not going to work out too well after about 20 minutes. But it is something that we want to try and do in these rooms. Now, actually, let me just give you a little side on impermeability. Has anyone ever thought about air quality in cinemas? Probably not a massive thing that people consider. So right now I'm talking to you live from my little office out in my garden. And I had a problem that at the end of the day, I was getting a bit sleepy. So I put an air quality monitor in here to find out what was going on. Now, of course, this room is all nicely sealed up to make sure that it doesn't get cold on a day like today when there's 4 inches of snow outside. What I actually found, though, is that my carbon dioxide level was 5 times the safe level by the end of the day. So it was good to know that we did a great job of sealing the room up, but really crappy to know that I've been poisoning myself for the last 8 years. So impermeability is an important one to remember, but along with that comes air quality. And although, of course, we're not talking about that today, I think you'll find that air quality is something that people are very, very, very interested in at this minute in time. So there's another quite a good opportunity for you guys to be aware of those things. Now, if you've got a client that's fallen asleep at the end of a 2-hour movie, could be the wine, but I'll bet a lot of it's also to do with the air quality in the room. You know, you've got 8 people breathing out in a cinema. You're going to get a lot of carbon dioxide, and that makes everyone sleepy. So you do need to think about air movement in these rooms as well. It goes actually hand in hand with sound isolation. So next, let's look at room construction. So here is a really nice graphic, which I have pinched shamelessly from the guys at Acoustic. Another Yorkshire company, incidentally. So I like to work with the guys at Acoustic because they make it very straightforward how much things are going to cost. So what you see on the screen here is a really, really high performance wall solution. It's a really high performance. It's 72 RW. which is an extremely high measurement of sound reduction, 72 dBs basically of sound reduction. Now that wall, the materials for that cost about £55 a square metre, give or take. So I like that because it's kind of the most extreme example that you would need to go to for sound isolation, but also the cost is not that bad at all. Obviously, you've got to factor in installation on top of that, but when you're talking about this with your clients, it's not like asking them to give up, you know, one of their kids or anything like that. It's £2,000–3,000 to do it really, really, really to a pretty high level if they've got a good contractor. And in fact, the guys at Acoustic will do all this type of stuff for you as well if you ask them. But a normal contractor should be able to handle these types of things. So if we look at this build up here, first of all, we've got mass, so weight in the structure. So in this one, let me get my little laser pointer again because I know that the writing is small. So what you've got is actually multiple layers in this construction. On the front here, you've got what they call plasterboard. It's an amazing substance I'm sure you guys have heard of. You will know that you get different types of plasterboard, of course. The main difference between those boards is really in the density of them. If you've tried to lift up acoustic boards that are full sheet, you'll know it's pretty heavy stuff. You can actually save quite a bit of money by using Fireline over real acoustic board. If that's one of those things that you need to save a few quid on the job, there's not really that much difference in performance between them. But that's the big thing that you're looking for, it's the density. This particular system, though, also has a thing that the guys at Acoustic call a sound plank, which is a really, really heavy composite material. Now, one of the advantages of using a composite material behind plasterboard is it gives you a fixing everywhere. When you're needing to put screws in, it's pretty easy because you've got a bit of wood basically to screw into absolutely everywhere. So in fact, it can be a really good way of making the room just easier to work with in general. So those two things are adding really the main mass into this. The second thing is that there's a material called Texsound. So Texsound is like a membrane material. If you haven't seen it before, it's like sort of rubbery stuff. You get it in 3mm and 5mm. So even the 3mm Texsound weighs 5 kilograms a square meter. So it also adds a lot of mass, but it's kind of squidgy. It squeezes. So it adds damping into the system as well. It also comes sticky backed. So when you put that on, it actually fills in all your seams and all that type of stuff. Texsound SY50, a roll 7 meters by 1.2 meters is going to cost you less than 100 quid. So again, it's not an expensive material. And actually, if you look at its fire rating properties and all that type of stuff, you probably find it's the sort of thing that you want to have a roll or two in the back of your van for doing in-ceiling speakers and all that type of stuff. It's just a great material for people in our line of business to have something like that. You get it sticky backed and not sticky backed as well. So pretty easy stuff to work with. So damping is the next thing. So damping meaning that when the sound hits a surface, that the surface is able to flex a bit like that. So in this one here, these silver rails are what the system is mounted onto, and they are mounted with a thing called a mute clip. It's like an isolation. You'll see it in ceiling hangers and all that type of stuff as well. You get the little rubber bushing that goes through it. and that allows it to move without transferring the energy into the rest of the structure. And as I mentioned, you've also got the text sound there. Then decoupling. Well, the mute clip is also doing that. What you have in this is you have the brick wall. Then you have the stud wall. Now that stud wall is actually spaced off the brick wall. That's important. It doesn't need to be miles off it. It just needs to not be touching it. That's the important thing. Now, when that stud is actually built, what you do is you put a layer of neoprene above and below the header and the footer on your stud work. Now, what that does is that stops the stud being coupled to the ceiling and to the floor. That's an important little step, and it also helps to seal around the stud work. Again, you can buy that. It's a reel of stuff that's, I don't know, just a few quid. Looks like a big roll of tape, basically. Then those clips that I mentioned, they're actually mounted onto the stud. So what you've done is you've completely decoupled this side of the wall from this side of the wall. You'll hear people talk about room in a room and stuff like that. That's really what they mean, although they sometimes don't realize they mean it. It's decoupling one side of the structure from the other side of the structure. Okay. Then the final thing is just the impermeability. How do we stop the airborne transfer of noise? Well, that's your Rockwell being used in there. Your tech sound obviously is doing a good job of that. But then the final thing is that all of this gets sealed with a bead of acoustic sealant as well. Okay. So if later on, guys, if you go on the Acoustic website, you will actually find like really detailed PDFs and all that type of stuff of these systems. They're very good. They don't try and hide or anything like that. They really make it so that if you just want to buy the materials, you can do it yourself nice and easy. Okay. So we'll do that. So we've been recommending this sort of construction for cinemas for many years now, especially with the tech sound material. And I can tell you it works extremely well, extremely well. You can do slightly simplified versions of this as well that are much, much less expensive. So it doesn't need to be a huge investment for your client. And honestly, it's more often than not a labor saving for you when it comes time to finish the room to have done this. Now, of course, if it was as easy as that, everyone would be doing it. The problem is that we get weak points. So building a nice big wall structure like we just did is the starting point, okay? Can anyone imagine, though, the problem with that big wall structure? At some point, you're going to have to put holes in it. It's very sad, but, you know, at some point, you're going to have to put some holes in it. Generally, you do need to have a door. You can try, but I think the client will object if you suggest not to have a door in there. Windows, you know, if it's a basement cinema, probably not, but yeah, a lot of other rooms do have windows. Power sockets, that's a classic one. If you're doing a double stud construction, so let's say you've got a games room on one side and a cinema on the other side, it's very easy without really meaning it to cut a socket at the same place on both sides of that wall. And what you do is you make a direct transfer point for that sound to go sailing straight through. Sounds like water. It will always find the path of least resistance to go flying through. So it will go through that hole like you wouldn't even believe. And then speakers, you know, those pesky in-wall speakers. Yep. You have to cut big holes for them. that's where honestly text sound is your friend. If you can plan it, you can capture so much of the sound with that material. Now, this is something that I cannot emphasize enough. Sound isolation is different from a lot of things that we as AV integrators can get involved in, right? Sound isolation is really a specific, detailed part of the building regs, because of course sound isolation in multi-dwelling buildings is a critical concern within the building regs. And there are very strong rules about that. And of course, there are companies that do nothing but measure sound isolation performance. Now, I mentioned the wall in the last slide, about 72. The guys at Acoustic are very, very careful to have big asterisks and stuff. This wall will be about 72. Now, the actual performance of that, as I'm sure you will understand, is linked directly to how well it's been built. If someone forgot to put that acoustic sealant in, it's not going to perform to the same level. The guy went and he put up the stud wall without putting those isolation pads under it. You know what? Now it's coupled to the building. It's not going to perform the same way. Therefore, if you are not doing the sound isolation, you've got to be prepared to manage that much more than you would do for general construction, because you've got to make sure that all of those little details are getting addressed throughout that process. Because as you can imagine, there is nothing worse than you get to the end of the sound isolation part of it. You put a speaker on and you want the sound come sailing through. That's heartbreaking, and I've seen it many times, and I can assure you the client doesn't go, oh, well, better not luck next time. You've got to be aware, you've got to have that attention to detail, and don't over-promise on something. If you see a rating, take 10 dBs off it. Make things safe for yourself, because there will be things that are they're just out of your control when you're doing this. Now, I have a picture here. I was going through all of my pictures, and the reason I chose this one is because it kind of lets me explain a little bit of this discussion about attention to detail. So what you're looking at there is actually a door opening in a double stud wall. This was my old demo room, actually, that was done this way. Now, how many of you, you're on site, you see the joiner putting in the door set? Okay, so that opening's been chopped in the block work. The guy comes up, puts his door set in, he puts his packers in to level it all off. He goes, that's me done. Well, you've still got that big gap around the door. Big gap. Depends how good the chopping was done and all the rest of the stuff, but there's always a gap. Same with windows. There's always a gap around those windows. Now, of course, the fire regs now are a bit more detailed about how those should be finished off. But it's actually very, very important that all of those gaps are filled. That blue stuff that you see on the picture there, all that blue stuff, all that is acoustic sealant. Now, acoustic sealant, you get it in Screwfix. It doesn't really cost much more than normal sealant, but what it does is it remains flexible. That's the big difference with acoustic sealant compared to normal sealant. It will remain flexible. So it has that little bit of give, and it fills the gaps better. So all those little things that you're looking at on the project, if you're involved with the sound isolation, they all add up. Seal around the doors. Make sure that the windows get a good seal on them. Look for areas that you might not have thought about. You know, is there a drop ceiling? Is there pipe work that's going through from the cinema into another room? Has that been sealed up properly around that? I can give many examples. There was one, it was actually a Middle Eastern royal family, and one of our guys went over to check why the sound isolation wasn't working. They'd built these incredible walls and doors and all that type of stuff below the ceiling level, but when he looked above the ceiling, there was no separation between the spaces. It was one giant open attic area. So the sound was just going up and over the wall as if it wasn't there. Incredible stuff, but that's what we found. So just attention to detail, if you are serious about doing sound isolation, is one of the most important things that you will have to remember, okay? Now, moving on to acoustic treatment now. Just a reminder, guys, questions, we'll take all of those at the end, okay? So the goal of acoustic treatment is to improve the sound quality within a room. It's not to block the sound or anything like that. You might get some impact, but that's a secondary benefit. That's not your primary goal of acoustic treatment. Now, sound quality, it's hard to quantify. One man's amazing is another man's nightmare. So it's obviously linked to personal preference, but there are some general things that we should consider. Clarity of the sound, the focus of the sound. So focus is imaging and things like that. You know, how well placed are the voices and the instruments within the sound field? Envelopment, that's a big one. You know, everyone, 53 channel Atmos systems and all that type of stuff, okay? That's envelopment that we're trying to do there. And then dynamic range. That's the difference between the quietest and the loudest parts. That for me is actually one of the biggest things that separates a really high-end system from just a good system, is the dynamics. Should start and stop and go from quiet to loud and back again in a heartbeat. Now, what is easier to define though are measurable factors that improve the sound quality. So we've got a little acoustic treatment tool set, and I call these the 3 R's of acoustics. So my company, CATS, is literally built on this principle of the 3 R's of acoustics. That's resonance, reverberation, and reflection. Now we're going to go into these a little bit more here. So resonance. This is where I can spend probably 3 hours just on resonance, by the way. So this is the most difficult one to shorten for this 1 hour presentation. Resonance is those low frequency waves bouncing backwards and forwards in a room. Now, because those waves are so long, at certain frequencies, those waves become a multiple of the room size. And what happens is that the sound pressure level varies at that very specific point, at that very specific frequency. Now, back in the days when we could do face-to-face training, one of the coolest things that you can do is take a subwoofer and put it in the corner and get people to walk around the room as you do a frequency sweep. Because what actually happens is there are certain frequencies where you can be stood in the corner next to that subwoofer and your body is about to melt because it's getting shaken so much. If you walk to the correct point of the room, the dead center being one of those points, you can't hear it. That's a spatial acoustic issue. The bass just doesn't exist at that point because of room resonances. It's actually hard to believe, to be honest with you, until you experience it properly for the first time, just how dramatic that is. Now, you may have heard this mentioned as a standing wave. It's the same thing. I always refer to them as resonances. So what treatment options do we have for resonance? Well, room construction. Damping of the room is actually one of the most important things that impacts resonances. You get a resonance because that wave is bounced back. So if you can reduce the bounce back, you reduce the effect of the resonance. So in fact, that plasterboard room is actually a really efficient bass absorber. Crap for everything else, but for bass, it does a good job, okay? The room layout, the actual way that you've got the stuff laid out within the room is one of the most important acoustic treatment tool sets. People don't realize that. That comes for free. It can make all the difference in the system. Then, of course, you've got dedicated products. So here is a dedicated product. That's a special type of bass absorber, which is only 43 millimeters deep. If you see normal bass traps that people talk about, they are very, very deep. They can be a meter deep. I don't know the last time you guys met someone that was willing to give up 1 meter of floor space for a bit of acoustic treatment, but it never happened to me on any of these projects. So we had to come up with something that worked properly, but didn't take up all of that space. So that's one of my own products. I'm very proud of that. I have to tell you, it's a fairly unique product in the marketplace that does what it does in such a shallow depth. Now, the next one is reverberation. So reverberation is just how the sound bounces around in a room. So, you know, think of that kitchen that we were talking about at the start of the training class. Someone talks and it takes a certain amount of time for their voice to decay. You'll hear that referred to as the reverberation time. It's just how long the sound takes to decay away. Now, too much reverberation is a bad thing because it masks the sound, but too little reverberation is also a bad thing. Now, things that affect reverberation, it's soft furnishings, really important part of it. Carpet. You need to put a big area of carpet. It's super efficient at high frequency absorption. Doesn't do anything for your bass, but it'll take all your high end away. People. Did you ever think of that? You put 8 sacks of meat and water in a room. They are quite absorptive to high frequency sound. Believe it or not, you get a standardized acoustic model of the human body, because you need to do that if you're doing concert halls or stadiums or anything like that. They need to model how the sound changes based on the capacity. Of course, you get dedicated products. So dedicated product for reverberation, that's your foams and fiberglasses and stuff like that. Okay, those are the types of products that are used to treat reverberation. The final thing is reflection. So reflection is the way that the sound, you have a sound from a speaker that travels directly to you, but of course you have the other elements of that sound that bounce off the walls before they get to you. And that sound bouncing off the walls, those are the reflections within the room. Now they have a really, really, really important role in sound, believe it or not. Now what affects that? Well, obviously the wall finishes and ceiling finishes. Hard furnishings tend to have more of an impact on the reflections. Decorative items, you know, anything that's in the room that sort of breaks up a sound, scatters it when it hits it, has a big impact on that. And then of course you've got dedicated products as well. So again, that's one of our scattering panels. Now, if you can see that panel has got lots of surfaces on it. And what those surfaces do is they break up the sound that hits it. They scatter the sound that hits it. So instead of having one reflection, when they hit that panel, it's broken up into multiple reflections. So that reduces their level and increases the decay time. Now, that's a really important part of my own personal acoustic philosophy, which I've made a company on, and which I guess probably a lot of you have heard. The guys at Meridian also have that system in their theatre and in their media room, if you visited that room also. Now, for some reason, the first reflection point is the hot ticket in acoustic treatment. What you will find is that some people tell you to take a big piece of fiberglass or foam and put that at that first reflection point and try and absorb the reflection. The problem that you've got, though, is unless that material is extremely thick, it does not absorb over all frequencies. So what you do is you change the tone of the reflection. The reflected sound is different from the direct sound. It also won't do much to spread out or vary the time of that reflected sound. Now, there's a really cool effect that you can look up called the precedence effect, and the law of the first wave front. And what that says is that your hearing will localize a sound on the first wave that arrives. So that's the direct sound from the speaker. But then the other reflected sounds, if you can reduce them in level and spread them out, they help your brain to understand the sound. Your brain processes really fast, and it helps to improve the intelligibility of the system. It helps to improve the spaciousness that's perceived within the system. So in fact, we don't try to absorb those reflections, we try to scatter those reflections. It's really interesting. We've done so many of these things now with really, really high-end customers who know sound very, very well. There's 1,000,001 studies on this as well. People who prefer that absorbed sound are studio engineers. It's recording engineers that are used to near field listening in recording studios. Okay, the products and the method I'm talking here is not for them. But for basically everyone else, that spaciousness is much, much more desirable than absorbing all the sound away. Okay. Good. So common mistakes, of course, like anything, acoustic treatment has some common mistakes as well. There is one mistake above all others that I see all the time on every third post on Facebook. Okay. It's too much absorption. Now, people do this with all of the best intentions. They put loads of fiberglass in down the walls to dampen the walls. I had actually, when I was doing these slides, I thought, you know what, I'll check this out because I don't want to say anything too controversial in this training. So even on the Rockwool website, they talk about sound dampening and not over dampening and stuff like that. Okay. Absorption in that kitchen that we've spoken about with all those hard surfaces, yeah, that's not a bad thing to do, to bring that down. But we don't want to do that in our cinema. Because what it does is it robs the system of dynamics and envelopment. So if you've been in enough cinemas, what you find is that if they're over damped, you'll be sitting in one row and your mate will be sitting in the other row, maybe the client, and you'll be talking to each other. And what you actually find is it's difficult to talk. After a while, you find that you're putting more effort. You're really trying to speak so that the person can hear you clearly. And without realizing it, what you've actually done is you've robbed one of the most important bits of our hearing system. All of those spatial cues and the extra information that the brain uses to get speech clarity. By absorbing everything away, you've got rid of that. So it's only the direct sound that's left to you. The same impact is happening to your speakers. Your speakers are having to work much harder to deliver that loudness that you're looking to have in the room. Now, obviously, absorption to an appropriate level for reverb time. I see that we have Peter on, and some of the standards work that CEDIA are doing. Quantifying the correct reverb time is an important part of that. So absorber panels do have an important part of the tool set, but these big, flat, continuous areas of rock wool or foam, it's something that you should try to avoid. Now, I like to think, even for me, every day is a school day, okay? So one of the things that when I was developing the CATS system 6-7 years ago, when you start to get into acoustic modeling, what you can start to do is you can start to look at the reverberation, not just as a homogeneous thing throughout the whole room, but you can actually start to look at it on different axes. And one of the other things that's actually a challenge in a lot of cinema designs is carpet. Many times do you hear it, put a thick carpet in, make sure the carpet's got a porous backing, put a horsehair felt underlay underneath the carpet to absorb even more stuff, right? That's acoustics 101 that you hear. The problem is that only starts to absorb from about 2 kilohertz. So what you do is you take all your high frequencies away by doing that. So you can do a killer acoustic design where your length and width, you can get all your targets aligned. And then you get this curve where you've got a super long decay in the bass on the vertical axis and then no decay whatsoever on the mid and the high frequencies because you've sucked it all away with the carpet. So in fact, in a lot of cinema designs that I'm involved with, and what we get people to do is actually put some hard flooring around the perimeter of the room to try and give more balance in the acoustics on all axes. I've had so many great arguments over that, by the way, but it always works out superb. And actually it's really handy because you know what, then you've got a nice bit of hard flooring for the stairs and all that type of stuff. So, you know, you don't need to be afraid of these things when you're looking at acoustics. Just think for a minute of the average living room. That's a room in most people's houses these days that doesn't have too many acoustic problems, right? It does tend to have carpet in it, and it's got sofas and stuff like that, but it won't tend to have these big areas of materials. But all of those other things have served, and pictures and stuff like that have served to help balance out the sound. A bit of a cabinet or whatever else, some shelves, you know, they all play an important role in getting this acoustic balance. So I mismentioned it a couple of times already. Outside of the cinema, the opposite is often true. You don't have enough absorption. If we talk about the kitchen, right, there's two obvious areas where you can get absorption into a kitchen without ruining the aesthetic of it. The first is to do it on the ceiling, and you do a stretch ceiling over that. And the ceiling could be backlit or a million other cool things that you can do with stretch ceilings. That's a really easy way of getting acoustic treatment into these spaces. Okay. Now, the other one is to do printed panels. You print on the fabric so that you can put absorbative materials behind that. And even one large picture can make a fairly noticeable difference in the acoustics within that room. You know, and a lot of these rooms have got artwork and stuff anyway. You can get mega high prints. The printer that we have is a 600 dpi printer for printing on fabric. So you can do very, very, very high quality work for that type of thing. And again, that's a great opportunity to add a few £100 onto the client's bill for not so much effort. Now, I mentioned the ease and clarity of speech when I was talking about the cinema. In these kitchens, that's what you want to start listening out for. If sounds are getting muffled, just because the sound is still present from before, it's a pretty noticeable thing. Okay, so room layout. So room layout is one of the most important, and as I said, least expensive tools for acoustic treatment. So good layout obviously is going to help you in all the areas of sound quality. If you get the speakers laid out properly, you're going to optimize your envelopment. It should help you a little bit with the focus and stuff like that as well. But for this particular example, we're really going to talk about resonance. So good layout is actually, it's the most important part of a good low frequency experience. And I have to tell you that no room correction system, no matter how fancy it is, or high-end subwoofer, is going to compensate for bad layout. Okay? That's just a fact, guys, as I will prove to you in the next 3 slides. So let's look at this example, okay? So here is a little room resonance example. That's been made with Cinema Tools, which is just a free tool. You can jump online and have a look at that. And what I've done is I've added on 3 listeners and 1 subwoofer. So here are 3 listeners, and here is a subwoofer. And I've done this on purpose. Okay, this is like a fairly typical layout that you'll see in a room. 1 sub at the front, just inside the front speaker, front left speaker. Then 3 people spaced off from the back wall. Typical thing, you see it all the time, okay? Side view showing the sub on the floor, and then that's your listener at about 1.2 meters. Simple stuff, normal stuff. But let's look at the frequency response for that bass. What this chart is actually showing us, that's the response at seat 1, seat 2, and seat 3. Now, what you can see is that even though those are probably, what, like a sofa, 3 people sat on a sofa, the bass that each person hears is completely different. Like this guy here at 100 hertz, what's that? That's seat 1. So the guy in the middle, it's like, man, this 100 hertz bass is crushing me. His 2 neighbors are like, no, mate, I can't hear it. How can that be? It's just physics. It's just where they are in the room. That's how those resonances are being energized by that subwoofer. And this is also why your room correction system cannot solve this problem for you. All a room correction system can do is turn up or turn down the volume at a specific frequency. Now, if it turns down the volume for this guy here, well, it turns down the volume for these guys here. They get a worse experience. Same thing over here. They're getting their heads blown off. He doesn't hear anything. That's right around your crossover. Look, that's just above 70 hertz. He's going to be like, man, there's no bass in this room. It's hopeless. Actually, if you moved off the center line, the bass in the room would probably be not too bad looking at that graph. But, well, you've put the guy in the middle, I would have thought. So, how could we solve that? In this example, what we've done is we've shoved another subwoofer at the back of the room. Okay. This one, it's the mirror image basically of this one at the front, but now it's at the back of the room. It's up high. Everyone always goes, oh, why, what are you going to do with that? Well, you use an in-wall sub. That's how you do it. You put it up high. And let's look at what that's done for the frequency response. So now the guy in the middle, Look, we've still got a discrepancy here, but what you can see is now the bass is much, much more consistent across those 3 seating positions. Now, what that means is this bass here at about 45 Hertz, your room correction system can perfectly correct for that so that everyone gets the same bass. Over here at about 115, again, room correction system will nip that right up. And by then you're up into the main speaker, so it doesn't really matter anyway. What about this one here, though? What's the issue that's actually causing these to be different? Well, it's actually this thing here, which is your 1, 2, 3, 4th axial length room resonance. This is where we can get into a full hour just talking about these things, right? That's a specific point in that room. It's a very simple to calculate where that is. If we kicked those seats forward or backwards 30 centimeters, that would solve that problem. Those would then align just as these other ones align. So for free, you would have gone from terrible uneven bass that no system can correct to beautiful consistent bass that's very, very powerful, and it's like nothing that your clients ever heard before. Okay, and that's the layout. That's just a mathematical issue that you've got to overcome. You will always, always, always have resonances. Have you ever heard people talking about splaying the walls and stuff like that to combat the resonances? It doesn't work. Forget it. How much are you going to splay the walls by? 45 degrees? 1 degree or 2 degrees, all it's doing is just moving the frequencies away from being easily modeled. Okay? It's pointless to even try it. You still get the resonances, they just are more spread out. My opinion, it's much easier to have them in a very known place that you can model and then address. And that's basically what I've shown you there. Okay. So we've gone over time, as always happens, but good news is that we've reached the end. So in this session, we've defined what is sound isolation, and what is acoustic treatment. We've also looked at the tool sets that we've got to address sound isolation and acoustic treatment. And hopefully I've shown you some critical points to look at for each of them. And obviously we're going to examine these in much more detail in future sessions. Okay, so thank you very much, guys, for your time today. I hope it's been useful.